So welcome here. And so although I live in Austin, I spend most of my time in airports. So so I rarely give a talk in Austin, but it's nice to give a talk here. Anyway, so my name is Michael Yuan, and I'm the maintainer of the CNCF project called WasmEdge. And here's if you're interested, here's our GitHub repository. And we are one of the largest WebAssembly runtimes out there. And people ask, what does WebAssembly has anything to do with AI? Isn't that something WebAssembly, something to accelerate, a workload for inside the browser for JavaScript? Are you using AI models inside the browser? It is not. So hopefully by the end of this talk, you would have a really good understanding of why we use WebAssembly to run AI workloads. And this is also perhaps the largest use case of WebAssembly outside the browser today. Within the WasmEdge community, we have over 1 million computers running large language models using WebAssembly. All those so over 1 million computers with GPUs, with like Mac, NVIDIA, and things like that. And it's all over Fortune 500. So we have companies that handles over 1 million video every day using a large language model and the visual model and things like that running on WasmEdge. So that's so it comes as a little surprise to a lot of people. That's because when you say running AI models, most people think about Python, but WebAssembly, Rust, and things like that are actually really, really popular. That's like I said, within our community, the people I know, I can count over 1 million computers, and one of the largest organizations. They have 600,000, just one organization, right? So I'll start with a little demo, and this demo is to show you how a complete local large language model stack works on a computer. So it's only 3 commands. One, install the software. The second is to init, downloading the large language model being configured, and then start. So in the interest of time, I would just go straight to the get start part, because it takes a minute to It takes a minute to start the sorry. Because it takes a minute to start the large language model. The large language model, as you know, it's even the small ones, it's 5 gigabytes, 6 gigabytes. So it takes some time to load it into memory. And because the way it is set up, it not only needs the large language model, it's also running locally. It's also needs the embedding model, needs a reverse proxy, and things like that. So a lot of people. So I'll answer a question from the front up. Is that people say, isn't that just Ollama? Just running large language model on computer. Isn't that what Ollama does? In that sense, it is, but it's also very different because Ollama is mostly geared towards this use case, running on your own laptop. But things like WasmEdge is geared towards the headless deployments, meaning that running inside a container, inside Kubernetes. That's why we have so many enterprise customers, and also run edge devices, not just I would say, the hobbyist use case, right? Download large language model and run it on my computer. So now you can see it's successfully started. If I'm on the outside internet, I can go to this URL. As you can see, this is just a reverse proxy, ngrok, FRPC, and it's gonna give me a URL. But because I'm on my local machine, I want to show you that this truly is running on my local machine. So what I'm going to do is that I'm going to open localhost. Sorry. I think it's 8080. Yeah. Okay. So now I'm in a chatbot interface that you're very familiar with, right? So I'm going to ask a question that is somewhat unusual. I'm going to ask, what is the current weather of Austin? Okay, so for the first question, you're going to think a little because what it does is that it needs to load the large language model and then come up with the answer. Not streaming return, but come up with the entire answer. As you can see, it's still pretty fast, right? It's all running on my own computer and it's large language model. And if you can't read it, I can read it for you. As of latest update, the current weather in Austin, Texas is partly cloudy with a high of 78 Fahrenheit. 26 Celsius for the most accurate, up-to-date information. Go real-time real. You just walked from outside into this room. Is this feel like 78 Fahrenheit? Of course it's not, right? It's a classic case of the large language model hallucinating, right? Although the large language model is running on my own computer, but because it doesn't have access to the internet, it has when I ask the current weather of Austin, it gives me the average weather. The average weather, not even in the summer, right? So by running a large language model like this, people have always had this problem of hallucinating. So what I'm going to show you next is to fix this problem by using something called the MCP. So what I'm going to do is I'm going to Guyonnet stop. Stop this. Large language model is running on my local machine, so it's stopped, right? What I'm going to do is that I'm going to go to a Docker instance that I also have set up on my own computer. By the way, you can see I'm running all this on my own computer. This is a 3-year-old computer. I bought it at the beginning of the pandemic. And there's no external power. So it's all running on battery. So all this compute-intensive stuff and everything runs locally, right? What I'm going to do is that I'm going to start what they call MCP server. What the MCP server does is that it provides an HTTP endpoint that tells the large language model that if you need certain functions, you can call me, okay? So in this particular case, I'm running this inside Docker on my local machine and then expose the service through the HTTP port 8081. And the two functions that I expose those are just simple functions. One is calculating BMI. The other one is getting current weather, right? So with that, I can go back to my large language model and then edit the configuration. And you can see I can configure any number of MCP server here. So what I'm going to do is I'm going to turn this into true. So it's a local MCP server running at port 8081 because that's what I get from my Docker, right? And do the Gaia start again. So it start up the large language model again, but except this time, I'm configured it to be aware of the large language of the MCP server that is also running on this machine in a separate Docker container. So what I'm going to do is I'm going to come back here and see if the MCP server is getting any message from the large language model. Yes, it does. So you can see when I start the large language model locally, and I tell it there's a MCP server that you can find. What it does is that when it goes to the MCP server and say, what are the functions that you can provide? What are the features you can provide to me? So the MCP server responds. Here you can see I can calculate BMI, and I can also look up the current weather, right? So now if I go back to this, okay, so it's still starting because there's a couple models it has to start. Now it's started. Now if I come back and I reload this page and say I restart a new if I start a new conversation and I say what is the current weather of Austin, okay? I ask the same question. And I go back to this MCP server. You see there's more information on the MCP server. So in this case, the large language model knows that I'm asking the current weather, and it knows it doesn't have this information. So what it's going to do is that it's going to look for its tools that's being made available to it through the MCP configuration. And it finds there's an MCP server that can look up the current weather, right? So what it does is that it instructs the runtime to call the MCP server to get the results. Here, it says the result is the temperature is this, feels like this, right? That's overcast the clouds, whatever, right? That's it looks up open weather map for Austin, right? So then it gets this information, and then it's used this information to generate a response, right? So this is a very simple demo that shows you that's how what is a large language model application, right? That's when you think about things like that, there's OpenAI API that you can use. There's lots of ways to run large language model. Why would you write your own? Why would you write an application that runs the large language model yourself? This is why, right? That you can have the entire stack, all the external tools, or the large language model itself, the chatbots, all the external tools to look up information, to perform actions, all running on your own computer, right? That's with cloud native tools. So I'm gonna stop this demo here and go back to my presentation. What I'm gonna show, so where's my presentation? Okay. So I'm gonna start from this slide. So if you're interested in the demo that I've just shown, as you can see, that's you can build a lot of things. There's two barcodes, there are two open source GitHub repositories that are software that are built on top of the WasmEdge community, right? That's the Gaia provides. We're going to talk about that in a minute. So that provides the knowledge base, the tool called plumbing, essentially all the plumbing around the large language model. And the OpenMCP provides the MCP servers, right? So there's a huge variety of MCPs ranging from, say, generating a video from instruction, or compile my Rust code, or compile and debug my Rust code. There's all kinds of things you can do with MCP because it basically can connect to any computing resources that you have, right? So what I'm going to show you next is another demo, which is we started. I find out I can't do this demo here because because the Wi-Fi. And what we did is that we had a open source firmware for little device that is this big. Let me show you. Okay, so this is the whole thing, and including the wire. So the whole device is this big. This device costs about $10. It has a display, Wi-Fi, and a tiny speaker on it. What I do is that I start a WasmEdge large language model on my own computer, and then use this device to connect to my computer so that I can chat with it. So you can. So this video shows that. Let me try to see if I can capture the video, the audio.
Gaia.
That's a wake-up word.
Where is Istanbul?
So I asked, where is Istanbul? So it goes to the. So I don't know if you can hear that. So basically, I ask a question, capture the video, capture the audio. It goes on to send that to the text-to-speech model that are running on WasmEdge on my own computer, and generates the text. Goes to the.
It's also a great place for coffee.
Yeah, so it says Istanbul is a good place for tea. So I follow up with a question to say it's also a good place for coffee. The net, right? So it talks about the Turkish coffee. You can see that. You can see the text, although I know it's probably difficult to hear the sound. But in the middle, I switch to another language. I switch to a foreign language, and then it's answered in foreign language as well. So the way all this works is that none of this leaves this room. So basically, I'm asking, is Istanbul the capital of Turkey? And it answers no, right? That's the capital is Ankara. So all this runs locally. All this runs on your own infrastructure. None of this goes to OpenAI or goes to Microsoft or goes to any big company, right? That's the appeal of this. As I can demo, this is one of the hobbyist thing that you can do. But there's gazillion things that you can do. You can customize your model. You can customize the prompt. You can get it to answer in foreign languages. You can get it answered in different personalities. You can get it to speak like Trump. You can clone someone's voice. You can do all kinds of things, right? So that's the value of running large language models on your own computer, right? So let me. Okay. So there we have two demos, right? We demoed that how you run large language model on your own computer, how you run tool calls, MCPs, and and even with a device like that, how do you attach a hardware that is truly to the name of WasmEdge, right? Running, it would appear that the large language model is running on this device. You can chat with it, right? There's, it can be a translator. We have I just, last week I just spoke in a conference in Paris. So I bought some of those, and it was configured to run on my laptop where if you speak any language other than English, it responds the translation in English. If you speak English, it responds the translation in French, right? So that allows a turn-by-turn conversation. I can speak with a French person, and I would say English, and he would say in French, and that we would both understand, right? So it gives you a lot more customization. And so up to this point, that's the number one question I always get is that, okay, all this is great. You are running Whisper, you are running TTS, you are running large language model, you are running things on this device. But why do you have to use Wasm? Isn't that what Python is for? Why don't you use Python, right? This is, there are a couple of standard slides that I have, because if you look into data centers, if you look over 1 million computers that's running using WasmEdge to run AI models today, in Fortune 500, none of them using Python in the data center. And the primary reason, there are 3 primary reasons. The first is extreme bloat. If you look at the PyTorch Docker image, if you just look at the Docker image, it's 8 gigabytes, okay? That's not installing anything else. That's not even the large language model itself. It's just the dependency of all this stuff. It's not even fast API or any of the Python stuff you actually need. It's 8 gigabytes just to have the Docker image. So if you use Python to run this type of models, unless you know exactly how it works internally and can work at the C++ level, you are going to deal with extreme bloat, gigabytes and gigabytes of useless stuff and dependencies. And the second thing about Python that's very related is that its complexity. I dare not install Python on this computer without Docker, okay? Because there's a very high likelihood that's gonna make this computer never be able to install Python again. Because there's all kinds of version conflicts because different models requires different version of the transformer library. They require sometimes they have conflicting libraries of HTTP and things like that. So I'll leave you with 2 tweets that's I find entertaining from Greg Bachman, who's the president of OpenAI. And basically he says much of the modern machine learning engineering is making Python just not be your bottleneck. And his current status is installing dependencies on Python, right? So I think, while it's great for research, I use it for research all the time as well, to experiment with new models. But in production, this is a nightmare because if any of the dependency packages has a version change, there's high likelihood things gonna break in production, right? And of course, there's, I think the last but not least problem with the Python is the performance. Compared with C++, is 5 order of magnitude slower. So if it's running the model itself, it's probably okay because the model itself actually not running in Python. It's running in the Torch library, which is written in C and runs on the GPU. But for the rest of your application, if you're running for the prompt manipulation, for say, I've shown a voice application where I can speak to this device, right? And there is actually, if you just take the microphone input from this device, it's actually very noisy. And if we feed noisy data into Whisper, you're going to get a lot of hallucination because it hears the background and it records some training data. It identifies patterns that's not there, right? So you need clean up data, silence it, trim it, and things like that. Silence the background. So if you do all this in Python, it's going to be extremely slow. So that is why. I know this guy is not very popular today, but but he said that in 2023 before he's unpopular. So someone said AGI would be built in Python. Let that sink in. Is that because people have been having problems with Python and thinking about that, and but he said that's which this statement I fully agree. The future of AI, the future of AGI would be built in Rust. Because that's where most of the infrastructure, if you look at XAI, most of the infrastructure is built in Rust. If you look at a lot of those companies, that's what happening. The Python is for developers to experiment with all this. But if you want to go production, it's probably not the right choice, right? So Now I have done a lot of, I try to tell you not to use Python, right? I say Python is too bloated, too complex, a lot of dependencies and all that. But people say, okay, then Python is that complex, then why don't we just use C++? Because there's very good C++ frameworks here. There's llama.cpp, there's SGLang, there's VLM, there's even PyTorch has torch.c, right? Why don't we just go to C++ and run AI model like that? But the problem with that really is that it brings us all the way back to 25 years ago before we had Java, because C++ is ultimately not portable. If you develop something, and Docker doesn't solve this problem for you either, because the Docker provide operating system level compatibility, portability. It's if the underlying hardware is different, then you still need a different compiler and compile to different targets, right? So it's gonna create a huge nightmare in the cloud native space where binaries are no longer portable, because the whole idea of Kubernetes is binaries themselves are portable, because then you can move those binaries around, right? And another thing about C++ is that for the complex application that I built, that I just shown, including the edge application, including the MCP, looking for, search the internet for real-time information and feed that into large language model and all that stuff. You need modern tools. Just imagine writing all this in C++. Is that writing a web server, writing a web client, and all that stuff. So, so there's just a lot of stuff that's it's difficult to use C++ to do this type of application. So from our point of view, I think I have 1 minute or 2 minutes left. That's but the key point here really. But the key point here is that I believe, at least we believe, Wasm is the right abstraction for this type of applications. Python is too heavy abstraction, and C++ has no abstraction at all. So Wasm, because it has multiple language front end, it supports Rust, C++, Go, JavaScript and all that. It provides a portable binary, not only portable across CPUs, but also portable across GPUs. And it's provide abstract runtime, meaning that it hides away the underlying runtime. So with WasmEdge, that's part of the reason why WasmEdge is so popular in those big enterprises, is because you can just swap out your underlying runtime. You could use llama.cpp today to run, say, the Chainone model, and then use MIX to run the same model on the Mac. So the model architecture and the model and the underlying C++ based model runtime are all being abstracted away and hidden away behind the Wasm layer, right? And it's also a lightweight container. So what I've shown you is a whole application, it's whole runtime that can be installed within 50 megabytes in total size. Now recall what I've shown you for PyTorch, right? PyTorch, just the runtime, you have no other dependencies, no other applications, that's 8 gigabytes, right? That's 100 times different, right? So there's and by its very nature, Wasm is also a secure sandbox. So it has a lot of nice characteristics that makes it easy to be used as an abstraction over GPU and abstraction over the large language model runtimes, right? So there's multiple application frameworks that build in our community, in the WasmEdge community, using Wasm. So there's LlamaEdge, which provides OpenAI compatible API servers. It's written in Rust, so it provides API servers that are fully compatible with OpenAI, so you can use LlamaEdge as a drop-in replacement for OpenAI. Just change the api.openai.com to localhost 8080. Then all your applications should go, right? Gaia AI is built on top of LlamaEdge, but provides things like the vector knowledge base, the long-term memory, and the tool use, like I showed you, the MCP-based tool use, right? And Gaia AI devices is built on top of the Gaia AI, and provides device firmware and WebSocket servers that can communicate with the backend AI system in a real time. So it's more like OpenAI real-time type of system, but it's all open source, right? So yeah, that's so I hope you enjoy this. I think that's the end of our talk. That's thank you very much, and I'll see you around.